Welcome to the first introduction of the Core Maze library, which is based on my algorithms Core and Core Braid algorithms. The base class for all mazes is this one here, maze. It is an abstract class, so you can't actually use it as is. However, we have various subclasses, delta, hex, other predefined ones. We'll get to that, that's an interesting one, and quads and so on here. So looking at the quad, meaning this orthogonal maze here, you can see the sides are 15 by 15, and we don't have wraparound switched on. And then we have, after that, the scale of the cells themselves. These other mazes are the same in maze properties, maze size, and the scale, and for delta you have maze size and scale. Then we have the templates, and then game object parents. We have the templates and game object parents. So what these ones are here are, these are the ones that are the templates for the different pieces that make up the maze. The cells are optional, but corners and panels are always going to be necessary. Next, I want to show you this Maze Builder class. This is the one that actually tells the mazes to build their pieces, perhaps generate bounding walls, and then generate the actual mazes themselves. This is the base class, but there are other classes that will, subclasses that will make different kinds of patterns, like radial patterns or concentric patterns. I'll show you that later on. This is the most common one, however, and all of these three use the same one. So here it is, Maze Builder. Now you'll see here we have, upon start, we can create pieces, enclose it, and generate the maze. And we also have this braided option here, which means that we can make all the mazes, make these mazes have no dead ends. So here you can see there are no dead ends anywhere. Here we have a different maze implementation that bases its labyrinth on the surface of a mesh. So here we have used this sphere as the template. So when we run this, we now get a labyrinth all around the sphere. Now this particular one here is actually braided, but we can switch the braiding off as well, like so, and there it is. That's an unbraided maze with dead ends. Now, if we choose not to generate, let's have a look at, for example, the capsule. Then we'll see all the different vertices that make up, all the different walls that make up that shape. So when we then choose to generate, we will get a maze based on those vertices. Bam, like so. Now remember how I said we'd look at other maze builders. So here's Maze Builder Horizontal, which currently is designed specifically for orthogonal mazes. It will prioritize building the horizontal panels before the vertical panels so we can get horizontal mazes like so. This is still a perfect maze, it just has a specific pattern to it. We can also set a wall count here. Let's put 10 vertical walls first before we generate the horizontal maze, and we'll get something a bit more interesting. Now, this is no longer a perfect maze because we now have, it becomes a partially braided maze. Here we have a hex maze or a sigma maze where the concentric panels are chosen first. Now you can see it looks like a labyrinth, but there are actually choices, so it's not quite a labyrinth. If we switch on the radial, however, we can then see that it's kind of hard to see, but these are more likely to be radial than completely random. By contrast, here is a completely random one. It may not be too obvious, but this is neither radial nor obviously not concentric. But wait, there's more. I'm now going to show you how to add events and special tools that can configure your mazes even further. So this is a maze quad. There's nothing special about that. And I have not switched on wraparound. But what I have done is in the onCreated pieces, which is called after create pieces and enclose, but before generate, we can customize the maze even further. So I have defined here a room. We set the boundary and we set the internal state. So there's the boundary and there's the internal state. I'll show that in a moment. And then we set a single block to open. Now a panel is really a block. It's a very thin block, but there are other kinds of blocks as well. And then we do a couple of join cells. So we join that cell to that one, and we join that cell to that one, and we have what looks like a Pac-Man maze. So let's look at these different features here. So here's the maze room. We specify the lower left is in the 4x4. That's this cell here, and the size is 3x2. 3x2. And the boundary state should be closed, and the internal state should be open. Then we have a single block here that we set to open. That's at 5, 6. That position there. Direction 0. So that's a horizontal one. That's something that's in the documentation. And then we have join cells. We have 2 of those, so we can join these here, and we specify the coordinates and which panels we join. But there is one other important feature about Pac-Man mazes, and that is that they are symmetrical. So if we have a look at the maze builder, it's a maze builder symmetry. And we have specified that we want horizontal symmetry. We could also change that to be vertical and horizontal symmetry, and the mazes will look a little different. Like so, you can see that both vertically and horizontally they are symmetrical. And that can look good and work. But if we just switch that off, then we have only horizontal symmetry here, and the mazes are a bit more as you would expect a Pac-Man maze to look. So there you go. There's our ghost room. We have our wraparounds there. We have no dead ends anywhere because we have switched on braided, and we have random Pac-Man mazes. Now, do you remember how I said that panels are thin blocks? Well, here we have thick blocks. Each block is either an empty space or it is a wall. There are no cells in between, and this algorithm does not work for this kind of maze unless we make little cells. We need dedicated cells that go in between these different blocks. And if we do that, then we have these little cells here, and now this works. This is not what you would call a standard maze. This is what I call a block maze. Here we can have them diamond shaped, and this kind of maze works as well. I don't think it's possible to do this as a perfect maze. Now this is another example of a block maze. So if you have a look here, these white things are the cells. See, these are the cells, and then these are the blocks that are like panels, but each one separates up to 6 different cells rather than being a thin thing. This is where the block is a passage. And so from a distance, it looks like this. So you can move between the cells across like so. Also, I have included a facility to actually do pathfinding using breadth first search, and then a path colorer, so we can see what the paths look like. I'll switch this off, switch that one on, and bam, you can now see. So the darkest, that's your target, and then it gets lighter the further away we get from this point here. And pretty much all the demo scenes have this facility. So here you can see the different cells, and the white spaces here are actually blocks that are switched off. But from cell to cell to cell, you get further away, and the lighter they get. So there you go. I hope you find this interesting and you have a lot of fun with this.